In this video we're going to go through a couple of past exam questions that involve spanning trees. So let's get into it, and as we go through we'll kind of remind ourselves of the process of how to find a minimal spanning tree. So in this first one we've got a multiple choice question, so this is from a past exam one. Get that out of the way. So we're given a network graph. It's a weighted graph. We've got edges with numbers on it. And it says, which one of the following is the minimal spanning tree for the weighted graph shown above? And so you can see we've got these 5 multiple choice options and we've got to pick the right one. So I think the best way to do this question would actually be to highlight the minimal spanning tree on the graph, and then we can just pick the multiple choice option that matches our working. First thing to do is count up how many vertices in the network. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 vertices. 10 vertices, which means the, so I'm going to say this V equals 10 for 10 vertices. And that means that the number of edges, well, if we're creating a tree, the number of edges is always 1 less than the number of vertices. So before we start trying to come up with our minimal spanning tree, it's useful for us to know that we need to have 9 edges. Okay, so that's going to kind of tell us when to stop, because we'll know we've created our spanning tree. And remember that the easiest way to find a minimal spanning tree is you just start by highlighting the smallest possible edge or the smallest available edge anywhere in the network. And you then keep highlighting the next smallest and the next smallest, as long as you never create a circuit or a loop or anything like that. Okay, and then eventually when we get to 9 edges highlighted, we should have created the tree, and that's when we stop. So looking carefully through this network, and if you feel like you want to pause this and have a go at it first, that's a great idea. But here we go. Looking through the network, smallest edge I can see is a 6, so I'm going to highlight that one. Okay. The next smallest one I can see is a 7, so I'm going to go to that one and highlight that edge. Then we've got a couple of 8s. Okay, so doesn't really matter which one you choose first. I'm going to choose this one. Remember that we're just making sure we're not going to create any circuits. So there's an 8 over here as well. And we've done 1, 2, 3, 4 edges. So remember to keep track, because we're going to stop once we get to 9. Okay, the next smallest edge, I've got a 9 over here between G and F and a 9 between B and C. Now normally I could highlight either of them, but I'm actually not going to highlight this one between G and F, because that would create a circuit. And so I'm going to go from B to C instead. I'll highlight that 9. Okay, and so we're kind of ruling out the 9 from G to F, the edge from G to F. So the next smallest available one would be this 10 here, and we can highlight that one because it's not creating a circuit. And how many edges am I up to? 1, 2, 3, 4, 5, 6, so we've got a few more to go. Next smallest one is, there's another 10 actually, so over here, there we go. Next smallest is an 11 from C to D. Can't do that because it creates a circuit. There's also the one after that would be a 12. Got a couple of 12s in the network. I can't use this one from B to I, but I can use this one from D to G. Okay, because I'm still not creating any circuits. And you can kind of see at this point that we've got every vertex connected except this one to H, so we've got to kind of finish off the job. Remember, we're just going to pick the smallest available one without creating a circuit. Can't use this 12, can't use this 13 from A to I, can't use the 13 from B to G, can't use the 14 from D to E. 15 is the next smallest one, and that connects I to H, and it doesn't create a circuit, so we've got that edge there, and that would be our final minimum spanning tree. And so now our job, we've got the spanning tree, our job's just to find the multiple choice option that matches that. And conveniently enough, it looks like, and we'll check it carefully, but it looks like option A is the correct one. And yep, checking all those edges, that looks right. So the correct option is option A there. That's the one that matches our spanning tree that we drew. Alrighty, on to another one. This one's from an exam 2. You can see that it's a short answer question. It's not multiple choice. And this one, I've kind of cut out a few questions of this just to practice the spanning tree one. So this one says a factory requires 7 computer servers to communicate with each other through a connected network of cables. The servers J, K, L, M, N, O, P are shown as vertices on the graph below. So we've got a picture there. The edges on the graph represent the cables that could connect adjacent computer servers, and the numbers on the edges show the cost in dollars of installing each cable. So for example, the cable from O to N would be $400. The computer servers will be able to communicate with all the other servers as long as each server is connected by cable to at least one other server. The cheapest installation that will join the 7 computer servers by cable in a connected network follows a minimum spanning tree. So you can kind of see this one, and I wanted to include this one because it's kind of an example of a more of an application question with a minimum spanning tree. So we're actually finding out information about a real situation here. And then the question says, draw the minimum spanning tree on the plan below. Okay, so we've got a new picture with dotted edges, and we have to kind of highlight the dotted edges clearly to show the spanning tree. So same process as before. Let's start by thinking of how many vertices there are. And there's 1, 2, 3, 4, 5, 6, 7. So we've got 7 vertices. Excuse my bad handwriting when I do this. And so the number of edges that we need for a tree is 1 less than the number of edges. So we're going to need 6 edges to create this minimum spanning tree. And again, start with the smallest edges and keep going to the next smallest so long as you don't create a circuit. So J to P of 200 is the smallest one. Next smallest looks like it's 250. And then the next smallest after that, we've got a 300 over here. We've got a 360. Right, so we've done 1, 2, 3, 4 edges. Next smallest look like the 2 400s down here. So this is a nice easy one actually, because look, all these edges that we're picking, all the smallest ones are actually not going to create a circuit. So we didn't have any sort of difficult decisions to make there, and we've now managed to connect all the vertices. You can see there's no vertices that are left isolated. And that's because we've highlighted 1, 2, 3, 4, 5, 6 edges. So if the question just says draw the minimum spanning tree, well, we've done it. But as always, read the question carefully, because maybe the next question might say, you know, what's the total cost? And we have to add all those numbers together. But yeah, hope that seeing a couple of examples from past exams kind of gives you more of a sense of how this process works. And hopefully you're feeling pretty confident with it by now. Cheers, everybody.